So, anyone brings any question? Ada bawa salah nak? Ah,
Soalan lab tu,
soalan lab ah.
saya determine dia sebab ada MS ni, dia second order kan.
Ah,
Sebab ada dua order tu jadi third order kan.
betul?
Boleh saya elaborate macam mana nak determine dia second order, third order and so
Alright. Okay. So can I have the question? Okay, so the question is based on the lab, how to derive the mechanical system on your lab 1. So anyone at home, you can try to open lab 1 module. Okay. Try to open lab 1 module to see the clear question. So this question is taken from the lab 1 module. Okay. Tak nampak eh. You cannot see clearly at home. I need to make it more closer. Maybe. Ataupun. Okay. The question is, okay, thank you. Okay, the question is how to determine the order of this kind of the system. Yang belah sini tak nampak kan? Ni saya, yang penting saya try ni, adjust. Okay, I need to make it like this. Alright, so according to the system, this is x1t and this is the place for the x2t. Right. So in order for you to determine how many of the system, you need to see how many outputs there. So in this case, there are two outputs, x1t and x2t. So there are two outputs. So it means that you must have two sets of free body diagram. Because there are two outputs, you must have two sets of free body diagram. So it means that you have the first body diagram, FBD, free body diagram number 1, and also you look at the free body diagram number 2. Okay, and then based on that, you need to find whatever components that connected for every free body diagram. So let's say for the first body diagram, here, this is the area, is it? So what is the components attached to the first output? What is it? Let's say this is D1, D1, D2, K1, K2, K3, and M. What is the components that attach to the first FBD? D1, K1, K2. Okay. Other than that, no, is it? So if you Laplace all the D, K, is it? So it will be D1S, is it? D1S. And then this is only you get K1, K1. Alright. So the higher power of S here is S power of 1 only. So the highest for free body diagram is S power of 1. Okay, S power of 1 lah. So now, we look at the second free body diagram. Second free body diagram, we do the same thing. What is the components that attach to the second FBD? We have K2 and then MB2 K3, that's all. Is it? So when you convert to the, I'm sorry, I'm confused with the control one. It's supposed to be dx over dt, kan? This is not s, dx over dt, yeah? So the highest for free body diagram number 1 is dx over dt. Okay, sorry for that. And then for the second free body diagram, the highest is m lah kan? So it will be m d square x over dt square. So the highest is dx square over dt square. So you can combine the highest derivative for the first FBD plus with the highest derivative for the second FBD. So you will get third order of system. So at the end, you will get your A matrix will be 3 by 3. Okay. So, am I answer your question? Okay. Okay, clear about that? Because I'm quite confused. Because I'm also teach Control 1 this semester. So that's why I mix with the other class lah. So this semester I teach Control 1 also and also Control 2. So it's quite confused this semester. Okay. Okay, so this is how you want to determine the order of the system. So far, how about your experience during implementation of lab number 1? Is it difficult? Huh? Difficult lah? Difficult? How much difficult? Let's say you have 10. What is the scale? 10? 6 or 7. So which one or which part that you feel difficult? Huh? Okay, how about the modeling? Modeling macam mana? How about modeling, is it difficult? Some. Okay, firstly, I want to ask you about the modeling. Do you can do the modeling? Convert the system to the state space, can you do that? Okay. Anyone have problem with that? To convert from the mechanical system to the state space? No. You have the problem with that? Yes.
This question they only ask for output x1.
Okay.
I still have to model the x2.
Once again?
The question only asks for output at x1. When doing modeling, do I have to put output x2?
Not need.
Not need.
I forget lah what is the question in the lab session lah. Soalan dia apa? Lupa lah. Soalan dia Repeat step 1 until step 4 using translational mechanical system as shown in figure 4 by fill up the output performance in table 2.0. I think it did not mention any X1, X2 kot. Kat graf.
Kat graf dia X1 ni je.
Oh.
X1 will be the output.
So,
lepas tu dekat modeling ada dua output.
okay. Okay, so it means that according to the lab question, okay, the lab question, for this state space, you can find the output either using x1 or x2. So you can see that at the y equation, so you have x1t, x2t, x3t. Okay? Betul? At the y equation. So it means that this one refer to this output. Betul? Okay? And then x2 actually refer to this output. Betul? And then after that, x3t actually refer to the x2 dot t. Is it? Something like the acceleration lah, velocity lah, velocity for the x2 . So it means that in the question, they ask you to provide the output graph for x1 according to the lab module lah. So it means that you just connect, you just make it 1, 0, 0. So it means the output only x1t . The rest you just make it 0. Clear? So let's say if the question asks you to see what is the graph for the x2, so you just make it, what is it? 0, 1, 0. So let's say if the question asks you to see the graph for x1 and x2, want to see the graph kan? So you have two outputs, y1 and y2. So the first output is 1, 0, 0 to see the output of the graph x1t, and then you have the second output to see the graph for the x2t. So you will have two scopes lah. If you try to run the simulation, ni saya pedas. If you try to run the simulation, I believe for those who are joined the lab class will understand this one lah, what I'm talking about. Okay, for those who are joining the class. Since this is a third order system, you will have 3 integral. Okay? And then this is, what is it? x1. This one will be x1 dot. This will be x2, x2. This is x3, x3 dot. So because the question asks you what is the graph for x1 only, so you just connect this one to a scope. And then this is your output. So you just need to copy and paste this output graph je lah for the answer. Okay. Is it just logic kan? No. Just a very logic thing lah. Okay. Then this one. So it means that you just, however, when I explain about the FBD, you understand again how to. Okay. All right. Before I proceed, do you know why we have 1, 2, 3? What is the meaning of this? Huh? Third of the system. So, itu tak join kan kelas lab tu. So for those who are joining the lab session, previous lab session, I explained, is it detailed about this one? Not very detailed lah. But you give you some idea how to run the simulation lah. Okay. So that's what I teach during the previous lab session. Okay. Okay, done for the first question and second. Is there any question in order to help you to answer during the test? What you need to know, okay, since for the test, the topic will be covered from the first week until the last weekend. Okay. Alright.
Sometimes kan dia ada kosong-kosong tak payah buat kan. If we just do the specific one yang lain hubung macam this.
Okay. Alright. So your friend asked me about how to convert from the state space to transfer function by using the formula. Okay. However, your friend asked me if he do or answer the question in a very shortcut way, is it okay? The answer is you can do that. So I think you are not understand what I'm talking about, kan? Okay, so I will teach you. I will tell you what's the detail he asked me about. Actually, yes. I'm very encourage the student to do the shortcut way because you can save a lot of time. Yes, you no need to calculate everything. Okay. Actually, I know this is really possible. However, I want the student actually explore how to solve it. However, you already asked during the tutorial session, so I need to explain lah. Okay. This is about how to convert from state space to transfer function by using formula C S I minus A inverse B plus B D. Okay. Let's say I give you a state space. A matrix is 0, 1, 1, 0, something like that. Because I want to show how obvious this one. I need to make it many 0. And then B, 0, 1, C, 1, 0, D equal to 0. Okay. So now, because this is second order system, 2 by 2 matrix, so you just plug everything here in this formula. 1, 0. Okay, 1, 0. For the Si minus A inverse, and it's supposed to be have, you will get something like this lah. A, B, C, D divided by the characteristic equation. Betul? If you want to, you have Si minus A And then after that, you need to inverse it. So you will have this kind of set of the Si minus A inverse. It must be in this form, where this is the top one actually adjoin Si minus A divided by determinant Si minus A. Kan? So the determinant actually equivalent to characteristic equation, and the adjoint Si minus A, since this is second order system, you will get this kind of the form lah. So you just make it something like this, just replace A, B, C, D, the characteristic equation, and then you just multiply with the B here, 0, 1, plus with 0 lah kan. Okay. So in this case, you need to calculate A, B, C, and D. Kan? You need to calculate A, B, C, D, and D. I think for the second order system, okay lah. You just need to calculate four parameters, A, B, C, and D. However, for the third order system, you need to calculate how many? 9 kan? So is it, it will take so much time, is it? So how to reduce? Instead you are calculate 9, you can reduce to a few parameters that you just need to calculate. So what you need to do, you just try to solve this one. A0, B. So this is B. A kan? Yang ni dia dapat apa? D. Betul? Okay? A multiply with 0 plus B multiply with 1. You got D. C multiply with 0 plus D multiply with 1. You got D. Is it? And then 1, 0 divided by CE. Finally, 1 multiply with B plus with 0 multiply with D. You got. So in this case, to get the trouble function, you just need to know the B value only. You not need to waste your time by calculate A, C, and D. Okay, so this is how you can save your time to get the transfer function. So in this case, okay, so based on this question, I know that I need to find B value only. Again, B value only. So from the adjoint Si minus A, okay, B is coming from adjoint Si minus A. So what I need to do, firstly, I need to find, so what is the B value? So B coming from adjoint Si minus A. So firstly, I need to find Si minus A. So I get S, -1, 1, and S. Is it? Si minus A. Maybe I can show you clearly, step by step. So Si minus A, the Si is S00, S. Anyone know how to get this one, Si? Okay. Minus with A. 0, 1, -1, 0. So finally, you get Si minus A equal to, this one will be S. Here will be -1. This one will be 1 plus +1, and this one will be S. Okay, this is Si minus A. All right. I need to put it here. So now you need to find the adjoint Si minus A. So you use the 3T techniques. Okay, firstly you need to transpose First rainbow will be S -1, 1, S. And then after that, you need tutup. Okay. For tutup, because you just need to find B value kan. So you just need tutup at B lah. When you tutup at B, this is the B location. This is the B location kan. Betul? If we compare to this form, A, B, C and D. So this is A, B, C and D. So this is the B location kan. So you need to tutup at B. When you tutup at B, you get -1 kan. So in this case, you know this is -1. And the rest you don't care. You are only interested in this value only. Okay. After that, you need to apply the tanda, the sign. Kan? The sign it will be positive, here will be negative. So finally, at the end, you know your B value is don't care, 1, don't care, don't care. So you know this is your 1. Okay. So anyone who cannot follow this one, please let me know because this is a tutorial session. This is not a lecture. Okay, because the tutorial we are discuss and want to make sure you totally understand what we are discuss. All of you should understand. Okay. Okay. At home, do you have any question? Anyone can respond? Tak ada ya? Ada soalan dekat rumah? Hello, hello. Witness, do you have any question, Witness? Is it okay?
Okay, Dr. Soba.
Okay.
Witness? Alright. However, I think you cannot see clearly kan? Bolehlah tengok sikit-sikit. Okay, so it means that you are save a lot of time. Instead of you need to calculate everything, you just need to calculate the thing that you are needs only. So the rest you just don't care. Okay. So this is for the 2x2. It will be okay lah if you want to calculate everything. However, if 3x3, lambat kan? You are taking so long time to calculate everything here. A, B, C, D, E, F, G, H, I. So normally, if you would use this method, I think most probably you need to calculate for the adjoint SI minus A, I think around 1 or 2 only. So no need to calculate all the 9 things. Okay. Let's look at 1. Okay. Boleh? Boleh tak? Boleh ya? So I give you some time to digest whatever. If you have any problem to understand this one, you can discuss with your friend in order to enhance your knowledge lah. Instead of just listening for me, you can discuss with your friend. Try to ask your friend. If you do the discussion, you will be understand more regarding to the topic. Okey tak? Faham kan kenapa yang lain tak diperlukan? Yang dekat mana yang tak clear?
Memang macam ni lah.
Yang apa dia?
Dia ingatkan
C.
ABCD ni memang unknown.
Unknown lah, kita tak kira lagi. Kita akan kira kemudian.
Lepas tu C ni memang arrangement dia. Yang ni C, yang ni kau yang
SI minus A inverse.
nak beli banyak unknown lah.
Actually, kita starting from the formula. From a formula to convert from the state space to the transfer function, this is the formula. C bracket SI minus A bracket inverse B plus D. Yang mana? Oh ni pasal ni. Dia punya okay, you just need to know the formula to convert from the state space to the transfer function. This is the only formula that you must use. The formula to convert the state space to the transfer function, you must or you are compulsory to use this formula only. Matrix C bracket SI minus A, you need to inverse B plus with D. Okay, I think during this class, I teach how to convert from state space to the transfer function. I believe it during a few days before Raya. And then just only less than half of students join the class at that time. However, I just realized I did not upload the video until yesterday. Okay, I believe Nurin, you are text me regarding to the video. And okay, I just realized that I did not upload the video until yesterday. Okay, so hopefully you can refer to that video in order to understand how this formula is derived. Because during the lecture, I show how you get this formula to convert from the state space to the function in that video. And also in that video also, I give you some examples how to solve, how to calculate to convert the state space to the transfer function. Okay. And then you also can refer to the lecture note, because in the lecture note or slide, I already upload about before Raya how to do this process. Okay. Alright. Is there any question? Alright, so that's the third question. Is there any question from the back? Do you have any question? Nak tanya? Daripada 1, 2, 3, these 3 tables. Do you have any question? Ada soalan? Tak ada? Tak ada soalan? Bagus. Ni study kuat ni. Tak tahu tanya soalan apa? Pun tak ada soalan? You don't have any question? Okay. If you don't have any question, I have a question for you. So which one you think that most difficult in control 2? Which part? Derive what part? Modeling. So the modeling part to convert the system to the state space. Okay. Electrical lah. Electrical for mechanical I think quite straightforward kan. For the electrical, the key to make it easy, practice ya. There's nothing. Because for the electrical part, you need to be more creative. Yeah, sebab because there are so many possible ways for you to solve that kind of the questions. However, if you keep practice, you will find, oh actually, you can find the best way lah. Macam Dr. Strange kan, want to solve to kill the Thanos, there are so many ways. What is the best way kan? So that's the thing lah. Okay. There are so apa? How many million possible? Saya tak ingat lah berapa million possible to kill the Thanos kan. However, there is a one way. I nanti ya. Okay. So that's the thing lah only to solve for the electrical part. Yep. Okay, how to know the direction lah. Okay. So we go back to the first question during the tutorial to derive from the mechanical to the state space for the translational system. Okay, so this question want to answer how to know the direction for the translational mechanical system. Is it left or right, something like that? Kan? So I give you a very simple one. Spring ni, spring. Okay, this is a very simple one. And this is the output. How to know the direction for the free body diagram? Firstly, you have this kind of the question. You look how many output? Only one output. Okay, if you have one output, how many free body diagram you need to draw? Only one. So that's the key. You just draw one. And then after that, you see where is the input direction, left or right? I need to follow the same symbol, FTN. Okay. So next, how many components attached to the output? 3. 1. You have the component is M, you have K, you have D and K. Okay. So let's say for the translational mechanical system, it wants to maintain its original position. So this is the original position. Original position. So let's say if you give the input, you pull the input or the system to your right, again, the system wants to go back to its original position. So let's say if you give the input to the right, so it will move again. This is your new XT. Betul tak? Because so this system characteristic want to go back to its original position. So it means that what is the thing that will force it going back to the original position is the components that attach to this area lah. M, B and K. So in order to go back to its original position, the M will force the system go to the left. The damper also will force the system go to the left. The spring also will force the system go to the left. So in this case, in order, so it means that this is force, and force. So you need to find the force equation for this thing, because if force to the left is similar force to the right, so it means that is it will be maintained at its original position? Yes, yeah. Because you give this force, however, another force will move to the left the same amount. So is it will be moving? It will be not moving. So that's why you need to make this thing go to the force equation. So for the mass, the force for the mass is M. This is because if you have mass, F equal to MA. Kan? MA. F equal to MA. However, A also equal to this one. So that's why F equal to MA. Actually, this is A, acceleration. Okay. For the damper, F damper, the force is dV. Okay, dV. Damper value multiplied with the velocity. The velocity actually also equal to dxt over dt. Equal to d, this one lah. For the force, for the spring, the formula, this is physics. F equal to K, apa? Kx. So this is the force formula for the spring. Itu kita juga F equal to Kx. So at the end, you will get this kind of the, because the summation force to the left must be equal to the force to the right. So you just fill up this equation. Finally, you get M plus with K. So you just solve this one lah. Just make it the table. Xt equal to x1 t. You have xt, you have this thing, you have this thing. You need to convert to the state space form lah. Firstly, you have xt here. So xt, you just put as a x1t. Next, you have dxt over dt. So if you differentiate xt, you get dxt over dt. If you have x1t, if you differentiate x1t, you got dx1t over dt. So this one you can, in short form, you can write x1 dot, the same thing kan. And then in this case also, you can also name as the x1 dot t equal to x2. You can name it. Okay, you can name x1 dot t equal to x2 also. So let's say then you have d square xt over dt square. Okay. If you have x1 dot, here become x1 2 dots, and because you differentiate about 2 times. Here will become x2 dot t. Okay. However, is it you interested with this one? No need. Why? Why? Because the state space equation x dot equal to ax plus with b u, y equal to cx plus with d. Is there any 2 dots on top? So you just remove this one lah. No need the 2 dots there. You just need to consider when you do the replacement, everything with only one dot only. So then you just fill up there. So buat soalan ni lah. So you just fill up here. D square xt over dt square actually refer to the x2 dot here. So you have m x2 dot t plus with d dx over dt. You have two options. You can choose either x1 dot or x2 t. So which one you need to use, x1 dot or x2? X2 only, yeah. You got x2 t plus with k, x1 t equal to f t. And then you solve it everything, you just make it x2 dot t as your title. Finally, you got negative k over m x1 t minus d over m x2 t plus with 1 over m f t. Okay, and then you just fill up in the state space form. State space x1 dot t x2 dot t. Finally, you got x1 dot t actually equal to x2 t, kan? Firstly, we just make the template first before you fill up all the value. Plus with ft. Ft equal to input, y equal to C matrix x1 t x2 t. So now we need to fill up all the information. So this will be x1 dot t equal to x2 t. So the matrix will be 0, 1, kan? Here will be 0. And here will be negative k over m, negative d over m, 1 over m. And then the output is x1t, kan? So it will become 1, 0. That's all. Okay. So this is how you, the question asked me how to find the direction, kan? However, because we already halfway, solve lah this thing. So this is how you want to determine the mechanical system. I think for the mechanical system, it's quite straightforward. However, for the electrical system, I hope you can try to practice more and more and try to compare the answer in the exercise. And also, you can find many questions in the textbook that I share the link. Okay, I share the link, you can find the exercise from there. Okay, and then if you do the exercise, if you want to know the answer, you can come and see me to discuss your answer. Because I have the textbook answer. Okay, so that's why you can check the answer with me lah. Okay, clear about the direction? Tanya direction dia.
Saya dapatkan 10 tu.
Ini? Because the output is x1 xt, kan? Xt actually equal to x1t. Jadi y ni output. Jadi y kalau kita, jadi y equal to 1 multiply with the x1 will be x1 plus with 0 multiply with the x2 will be 0. So now the output is y equal to x1t. Because the output is xt, however xt equal to x1t, so that's why the here will be 1, 0. Clear? Okay. Ini tak ada soalan kan? So we go to this row lah. Do you have any question? Okay. Do you have any question? This row. Tak ada apa. Okay. At the back there, do you have any question? No, tak ada. Okay. Ah, okay. Macam mana?
You create one 3 times 3 to provide the table.
Okay. Okay, so you want to find the eigenvectors for the 3 by 3 matrix. Yeah. So you want to test, to try that kind of the question. Okay. Yang mana? This 01. This one. How to get this one? What's it? Dekat on top in here. This one kan? Okay. How to get 01 in from here? Okay. For this one you understand kan? S1 dot, X2 dot. Okay. Kita go to there. S1 dot equal to X2 dot. X2. So we extract this for information. This is X1 dot equal to X2. Okay. So that's why this is X1 dot equal to 0 multiplied with X1 will be 0. Plus with 1 multiplied with the X2 will be X2. So the outcome of this is actually equal to X2. Plus with 0 multiplied with the FT. 0 kan? There. So we extract this first thing. So now, okay, x1 dot t, we extract this equation x1 dot t equal to 0 multiplied with x1 plus 1 multiplied with x2, you got x2. Plus with 0 multiplied with the ft, well, 0 multiplied with the ft, you got 0. So now you got x1 equal to x2. Because when you develop this table, you know that x1 dot equal to x2. So that's why here become 0, 1. So let's say if you make it 1, 0, so here become x1 kan? Because 1 multiplied with x1, x1 lah. So now you got x1 dot t equal to x1. Is it correct? No kan? So that's why it become 0, 1 here. Okay? So you can get the information to fill up the state space firstly from the final equation that you develop. That's the first thing. And the rest coming from this table. Okay? Normally, at the end of the equation that you develop here will be the last row. Okay? The rest on top of here actually coming from this table. Okay. All right. Clear? Clear? However, you still can revise or see our class here. I will upload the recorded video lah in the YouTube, so you also always can refer to the recorded video. Okay. Okay. So the next question coming from the second row is about the eigenvectors. Okay. The question is about the eigenvectors. Soalan ya, soalan. I need to think of the question lah. Yeah. Okay. The eigenvectors actually Ax equal to lambda x. Eigenvectors formula Ax equal to lambda x, is it? Okay. Ax equal to lambda x. To find the eigenvectors, there is a few steps you need to follow. To find the eigenvectors, firstly, you need to find the characteristic equation by using determinant lambda I minus A. Okay. Based on that, you can calculate the lambda values. And then secondly, you need to use this formula to get the eigenvectors. So your friend asked me about how to find the 3 by 3 eigenvectors. Because during the class, I show you 2 by 2, 2 by 2 eigenvectors only. So this is about 3 by 3 eigenvectors. Okay, so let's say we are only interested which matrix from the state space. A, B, C, D. Which the matrix that we only interested to find the eigenvectors? You have A matrix, B matrix, C matrix, and D matrix then from the state space. To find the eigenvectors, which matrix that you are only interested? Huh? What is the answer that? A matrix only, yep. We just only interested with A matrix only to find the eigenvectors because you can see the formula lah. Lambda I minus A. Ax equal to lambda x. So in order to find the eigenvectors, you don't need to know what is the B matrix, C matrix, D matrix. You only need to know what is your A matrix only. So in this case, I just give you one A matrix example. 0, 1, 0, 0, 0, 1, negative 2, negative 1, negative 2, and negative 3. Okay. Alright. Okay, this is extra question. Regarding to this form, okay, this form of the A matrix, how many state space form that you can construct according to the lecture? How many form? 1, 2, 3, 4, 5? 5, yeah, correct. You can change your matrix, your state space, your transfer function to state space in 5 different forms. Okay, you have phase variable form, cascade form, apa dah? 3 lah. Parallel form, OCF and CCF. Thank you. Okay, this one which one? PBF ke? CF ke? Which one? PBF. Huh? Yep. So this form maybe lah. This is a PBF. The PBF used to develop which controller? Huh? Pole placement controller, that's correct. So this thing you will learn during this Friday, tomorrow. You will learn to develop pole placement controller tomorrow. Okay. Alright. And the other news is starting from next week, Dr. Siti Mahanis will take over the class. Okay, I'm not longer to teach you. Dr. Siti Mahanis will take over the class starting from next week. Alright. So now this is our A matrix. So firstly, you need to find the determinant Li minus A and find the lambda values. For this exercise, I want all of you try to get the lambda values. Okay, try to do it now. We try to check the answer. Okay, at home also you can try to solve lambda I minus A for this A matrix. Okay, you have this A matrix 0, 1, 0, 0, 0, 1, minus 1, minus 2, and minus 3. And then firstly, you need to find the lambda I minus A first. After that, you need to find the determinant of lambda I minus A. And then you need to factorize to find the lambda values. All right? You can try to do it at home. For those who are online. Okay. Yes. Okay, while you are doing that, do you know when we want to stop the tutorial class? Until what time? Nak buat tutorial class? 4. Okay. You have another 10 minutes. So this is our last question lah for the tutorial. Apa dah?
I'm still not used to this yet.
Ya. Itu. Do you get lambda I minus A? Something like that? If you get, yeah, oh betul lah. Try. And then check your answer in front. Is it in imaginary or the lambda value? You got the lambda value yet? You got the lambda value yet? Is it in everything in integer? Oh, this is imaginary, not suitable lah. Need to change the value lah.
Lambda tak boleh ada.
Boleh. Tapi for this exercise, boleh lah, try tengok lah. You got the imaginary value kan? Boleh? We try to solve with the imaginary value lah for the lambda. What is the answer? Negative 2.32. Equation 3 degree 1, 3, 2, 1. Okay, I want to ask the back row. Okay, according to that whiteboard, there are 3 answers that I ask you to check. Okay, the first is the lambda I minus A. Second is the determinant, and finally the lambda value kan. So firstly, I want to ask, anyone have problem to find the first answer? Lambda I minus A. Okay, all of you can get lambda I minus A. Okay. Second, try to find the determinant lambda I minus A. So I need to check you can do it or not. So for those, any of you from the last row, if you cannot find the determinant, tell me. So we will do it until you can do that. Okay. Try to find determinant. So for the answer, okay, go to the second part. Okay, for the second row, for the first answer, lambda I minus A, okay. All of you can get the answer. For the determinant lambda I minus A, tengah buat. Alright, okay. So you also good. So which stage you are? Determinant lambda I minus A, tengah kira. Okay. So if you have any problem to get the same answer, let me know. This table, which stage you are until at the end? The last stage? So for the first and second, you get the same answer? First and second? Okay, so which part do you struggle to find? Okay, so after you got lambda I minus A, so now to proceed to that part kan. So to get the determinant, you need to follow this step. 2T. 2T Tutup and tanda. The first T you need to tutup. Okay, so you need to find, let's say this is your, okay, sorry. You need to find any rows or column. What do you prefer? Okay, I draw it here. Determinant you got lambda negative 1, 0, 0, lambda negative 1, 1, 2, and lambda plus 3. Okay. So I show you how to get the determinant. Okay. Although, because I want to make sure you know every step here. If you know every step here, you can do a lot of the question. Okay. If you stop at this part, you cannot proceed to answer the rest of the question lah, or the other type of the question. To find the determinant, you need to choose any row or column that you are interested or with many zero, because it will make your calculation easier. Okay, for me, I prefer this one lah. You can choose any. You can choose any. Alright. So in this row, you got lambda, negative 1, and 0. Okay. So you just extract all the information here. You got lambda, give some space here, negative 1, give some space, 0. Okay. Now, you want to find, firstly, we focus on the lambda value only. So this is the lambda location. So in this location, if you close the lambda value at the horizontal and vertical, you got only left this kind of value. And so you just write down whatever value that you get, the left. So it will be lambda negative 1, 2, lambda plus with 3. Okay. And then after that, if you want to focus on negative 1, so you need to close the horizontal and vertical for negative 1. So the rest will be, what value? The 0, negative 1, 1, lambda plus 3. Ni dekat sangat kan? However, if anything multiply with the 0 will be, so you not need to find lah. Because this thing you need to multiply. You need to multiply the value here, multiply with lambda. The value here multiply with negative 1. The value here need to multiply with 0. So for the 0, you not need to calculate lah. Kan? So that's why, if you want to find the determinant, you need to find which row or column that have many zero. So it will make your life or calculation easier. Okay. So now you just from 1, 2, 3, you just need to calculate only 2 only. Can, because of the zero thing here. So finally you got lambda. Ni multiply with this one, you got lambda square plus 3 lambda minus kan. 2 multiply with the negative 1, you got negative 2. Because this is the determinant, and we call it, because this the formula to solve this kind of the question, this one multiply with this one minus this one multiply with this one. This is how we calculate this thing. Okay. And then after that, alright, this is negative 1, negative 1. 0 multiply with this one will be 0 minus with 1 multiply with negative 1, you got negative 1. Okay. Mana? Ni ya? Yang macam dah? Dekat area mana?
Bukan yang ni, yang middle determinant dia akan negatif.
Nanti akan tambah. Saya akan tambah negatif nanti. Okay. Alright. Okay, you got this one minus 1, this one kan? Okay. If you still remember, I told you that for to calculate the determinant, you need to use 2T techniques, 2T techniques. So the first T you already done, tutup, until you got this thing. The second T is tanda, the sign, okay? So the sign here, you must remember the pattern of the sign. This should be positive, and here is negative, positive, and so on. And because we choose this row, lambda should be positive, the negative one should be negative. So you need to apply the tanda. So positive, this one should be negative, and the rest lah. Okay. So finally you got lambda cubed multiply plus 3 lambda square plus with 2 lambda. This is you got positive 1 multiply with negative 1, negative 1. Multiply with another negative, you got positive. So this is how you calculate the determinant. Okay. The determinant using the 2T techniques. First T, you need to tutup by choose any row or column that you like, which contains many zero. In this case, I choose lambda, negative 1 and 0 and write down lambda, negative 1 and 0. Finally, next, I close the corresponding parameters, and then after that, I apply the sign, positive, negative, positive, in order to find the determinant. Alamak, dapat 6 minit lah ni. Satu habis pukul 4 ni, tutorial. 4:30, okay. Extra time, injury time. Okay. So by using that technique, you can calculate any determinant. Ada tak siapa-siapa masalah to get the value? Faham tak sekarang ni? Okay. Sebab kamu tak check yang apa ni? Sepatutnya ni kamu tak check dia punya tu. Cuba buka sekali. Okey, negatif tu. Tekan sama dengan lagi sekali. Okey. Tengok ni. Bila ada arrow, maksud dia ada imaginary. Cuba tengok X1. Cuba kamu back balik dia tunjuk value X1. Ada tak R dekat situ, dekat calculator tu? Tak ada kan? Bila X2, ada tak? Jadi R tu sebenarnya tersembunyi di sini. Kamu tekan shift. Mana shift? Sama dengan. Itulah nilai imaginary dia. So you need to very careful. Dia biasa dah imaginary, macam mana kamu nak make sure benda tu ada imaginary. Bila kamu tengok value X2 and X3, tukar calculator tadi. X1 nombor yang lain. X2 nombor negatif 0.3376. X3 sama. Bila sama tu memang akan ada imaginary value. So this is how kamu tak terlepas lah. Benda tu sebenarnya ada imaginary value. Lagi satu kena check yang R tu. Dia tak. How is it for the still struggle start? So which one? Okay, we have discussed about the process kan to determine to find the determinant. So which part you start?
At this one, because I 0, -1, I get then the -1.
Okay.
I get this message.
So this one okay?
Yeah, just
Okay. So the determinant part?
also, and this is wrong because it's wrong.
Or it is wrong?
Yes.
Okay.
I get it.
Okay,
Yeah,
you got
first,
that.
wrong. You should just get that.
So it means that this is really you need to careful kan? Okay.
Lima, 3,
question yang
Okay boleh ya, sorry. Ya. Itulah. Dia kena spend some time juga lah kan. Betul. Minggu ni saya janji. Okay, bagus. Sorry. Okay. Ada apa dah?
replacement table tu selepas kita buat motion equation ke sebelum?
Lepas kita dapat motion lah.
Dapat ni kan?
Selepas kita mana yang tadi yang di apa semua tu? Kan saya ada buat yang kiri sama dengan kanan tu. Yang mana lah? Yang saya buat equation kanan sama dengan kiri tu. F kanan mesti sama dengan F kiri. Lepas kamu buat tu, sekarang ni kamu dapat benda ni kan. Ini F kiri dengan F. Ini bukan yang kita discuss tu.
Yang tu simple lah, saya ingat. Saya ingat. Makanya yang nak replace tu dia akan ikut mana satu?
Yang replace tu, okay. So because this is ada dua output. So finally kamu akan dapat dua equation. Equation yang pertama adalah free body diagram yang pertama. Equation yang kedua adalah untuk free body diagram yang kedua. So kamu akan dapat first equation untuk free body diagram yang pertama, second equation free body diagram yang kedua. Selepas kamu dapat equation tu, baru kamu develop replacement table. Okay. Kalau ikut case ni,
macam nak replacement tu, yang mana satu nak replace dulu?
dia mana-mana tak kisah. Yang penting kamu tunjukkan saya dulu equation free body yang pertama dengan kedua dulu. Tunjukkan saya. Lepas tu baru saya boleh explain.
Ini untuk dua output kan, saya tanya konsep saya betul juga lah. Macam ni dia ada X1, X2.
Okay.
So kalau macam ni dia pengen high konsep di X1 tinggi. So dia yang ni tak ada kan?
Tak ada.
So tak payah tulis yang ni.
Tak payah.
Lepas tu X2 yang baru lah.
Yang baru lah.
Kalau dia second order dia baru sampai
Ya, baru sampai itulah. Sebab dia bila free body diagram pertama, where is your free body diagram pertama equation? Yang mana? Kalau kat sini kan you develop kan equation untuk ni, kat sini kat mana? You cuba you tengok.
saya tulis terus lah.
Okay. Tapi memang itulah maksud dia. Tapi untuk make sure you need to know which up until what you need to replace. Firstly, you need to refer the equation for the first free body diagram. So you extract all the highest dx over dt. Tapi I believe the highest for the first free body diagram up to dx1 over dt saja. So kat situ you replace. For the second free body diagram, the highest will be d square x over dt square.
Kalau dia sampai X1 dot, lepas tu X2 yang baru satu.
Betul. Macam itulah. Okay, try to develop question tu.
Yang ni betul tak? Sebab dia negatif. Sebab dia ada effect tadi. Direction dia betul? Ke ada benda?
Tengok lah. Ini B1, K1, K2. Ini K2, X2. Yang ni dipengaruhi oleh
S1.
Okay. Buat dulu. Termasuk ada ini tak ada math kan? Okay. So I need to ask you the question. So dari segi for the first lambda I minus A, okay? Yang berdasarkan dekat whiteboard tu. Lambda minus I, okay. And then for the determinant. Okay. And then for the lambda value pun. Okay. Dapat Alright.
Kalau dia kan antara dua kita nak tahu direction dia tu kan
Macam mana dah?
K2 kan antara dua apa S2 dengan S1 kan. So bila buat FDD ada kat sini. Tapi dia tak faham pasal dekat sini.
Kenapa? Kenapa K2 tu menghala ke kanan?
K2 X1 ke kanan, K2 X2 ke kanan. Ni yang nombor 1. Mana K2? Ni.
Okey begini.
Tak faham.
Tengok. Alright. Kalau kat sini sekarang ni untuk the first free body diagram kan. This is our first free body diagram. Ini macam second je ni. Okey, itu kan. Bila this is the second free body diagram. Masa di input, kamu bagi input dekat sini kan, M ni. Bila tolak, yang lain akan melawan ni kan. Akan melawan. Tetapi disebabkan bila dia melawan kan, X1 ni sebenarnya akan tertolak ke kanan juga, betul tak? Sebab bila kamu tolak kat sini, kan, bila kamu tolak ke sini, yang lain akan melawan arah X2. Tetapi X1 ni dekat sini, betul? X1 kat sini, tetapi disambungkan dengan spring terhadap yang kamu tolak ni. Bila spring ni, jadi X1 ni akan tertolak ke kanan juga tak? Contohnya macam ni. Sebab dia bersambung Ini tak. Okey, macam ni Macam ni. Kita tutup ni dulu. Kamu tolak FP. Jadi yang semua akan melawan untuk back kepada original position kan. Tetapi spring ni bersambung dengan output X1, betul tak? Bila sambung dengan S1, adakah spring ni akan menarik benda ni ke kanan juga? Betul kan? Sebab bila kita tolak kat sini, yang lain akan melawan. Tetapi X1 ni akan terikut sekali sebab dia bersambung.
Maksudnya S1 tu dia akan ikut ST kau?
Dia akan ikut ST sebab apa? Cuba kamu tarik something. Kan? Kamu tarik something. Yang belakang tu macam kereta api lah. Kereta api kan? Bila kamu kereta api, ini yang pertama, ini gerabak yang kedua. Okey. Bila bergerak, brake ada kat sini. Yang ni tak ada brake. Okey. Ini ada brake kat sini. Bila kamu brake, ini output yang ini X1 ni X2 Bila kamu brake, yang ini akan berhenti, betul? Tetapi dia disebabkan oleh inertia, yang S1 ni akan teranjak ke depan. Betul? Jadi yang bila teranjak ni adalah sebagai force, akan jadi input juga. Akan dia menolak ke depan. Faham tak? Dia kena imajinasi. Okey sekali. Saya ulang sekali. Bayangkan ini gerabak yang pertama. Ini gerabak kereta api yang kedua. Gerabak kereta api yang pertama, ini gerabak kereta api yang kedua. Okey. Lepas tu kereta api berjalan. Berjalan kan? Berjalan. Tapi dihubungkan oleh spring. Spring ni kan dia boleh lentur, kan? Bila boleh lentur, dia bukan yang satu batang yang padat lah. Dia spring kan? Okey. Bergerak-gerak. Tiba-tiba yang ni kita break. Kita break disebabkan oleh spring, yang ni akan tertolak ke depan. Walaupun ni break berhenti, tapi gerabak kedua ni akan tertolak ke depan. Dia akan tolak. Betul? As input lah. Kita pasal dia directionnya untuk X1 ni ada sambungan direction input.
Saya tak faham lah yang tolak ni.
Dia sama je benda ni.
Tapi yang sambung, yang gabung dulu.
Gabung. Sebab apa? Tengok kat sini. Okey. K2 ni, benda yang sama. Jadi kita nak simplify equation tu.
Kalau spring tu dengan damper tu nak
sama juga. Benda yang sama. Sebab apabila kita break, ya gerabak kedua ni tak ada break. Jadi dia akan tertolak gerabak ni ke depan juga. Macam tu. Itu pasal bila dia tertolak ke depan, as consider as the sama direction input tadi. FT.
Kalau yang ni kan, Dia kan satu. Tapi kalau ada dua komponen antara dua ni.
Contohnya kalau macam K2 dengan ada K dengan K kan. Campur je lah K tu, tinggal satu spring je.
Kalau K dengan D.
K dengan D dia akan dapat 3 output lah. Ini output yang pertama, output yang kedua, output yang ketiga. Gitulah. So macam tu. So dia akan calculate sebenarnya level first, dia akan jumpa first series of the component ini jadi output. Jumpa another component jadi output. Jumpa another component jadi output. Kalau ini component output. Dia selang-seling. Component output, component output. Dia selang-seling. So untuk kamu kata ada damper kat sini kan. Spring damper component output. Spring output. Damper output mass. Begitu lah. Dia punya susunan dia. Untuk kalau tadilah yang kita tambah damper tadi. Itu another example. Itu.
Oh. Kalau soalannya soalan kan. Masalah macam ni kan. Kita punya space question consistent in PVF kan. Tapi kita nak dia bagi cert dah. Biasa kita kena obtain space cert ni lah dulu. Tapi kita belum convert to PVF.
Ya.
Kalau convert PVF tu kita akan putih kepada A je kan.
PVF semua. Dia cuma eigen value je pada A saja. Jadi bila kita katakan state space mesti A, B, C, D. Semua sekali. Alright. Okay. So according to this one, B K1 okay tolak K2 kan. Okay. So sepatutnya dx1 over dt.
Tak boleh terus. Tak boleh terus.
Damper. Sebab damper dx1 over sebenarnya ini adalah force equation.
Saya nak tunjuk ni lah. Nak tunjuk B ni daripada L1 je.
Tak. Sebenarnya bila free body diagram ni adalah untuk force equation. Bila kita develop free body diagram, sebenarnya kita nak develop force equation. Okay. Yang ni semua force ni. Force dan ini adalah force. Okay. Bila damper, formula untuk force damper adalah B dx over dt. Kalau force untuk spring, K x. Ini je ni force lah. Kalau force untuk mass, formula dia M over dt. Jadi bila dekat sini, kamu tak boleh tulis x1 je.
Sebab saya tulis lah tu, saya nak ringkaskan.
Kalau kamu nak ringkaskan, kamu kena tulis x1 dot. Kalau x1 saja salah. Okey, sebenarnya x1, kalau x1 dot betul. Kalau macam ni kan, ni K ini M, kamu kena tulis ini sepatutnya kamu kena tulis double dot. Betul ya? Ini kena tulis dot. X2 double dot. Sebenarnya nak X2 double dot dulu. Kita kena sebab untuk jelaskan ni kita kena step by step dulu. Tapi kamu faham kan kenapa M2 X2 double dot? Okey. Alright kat sini tak ada X3 lagi. Okey. So daripada first equation kamu list out. Kamu ada X1, kamu ada X2 dengan S1 dot. Betul? Okey. Yang kedua kamu ada daripada first equation, yang kedua kamu ada X1, kamu ada X2 dot dengan X2 double. Ni daripada equation nombor 2 lah. X1 kamu ada X2 dot dengan X2 double dot. Okay. So secara asas dia kamu ada group of X1, kamu ada group of X2, betul? Bila kamu combine sekali group X1, kamu ada X1 dot sahaja. Ada lain tak? X1 dot. Untuk group X2, betul? So baru kamu buat replacement. Jadi X1 kamu just namakan sebagai X1. Betul ya? X1 dot equal to X1 dot equal to X2. Okay. X1, bila kamu X1, kamu jadikan dia. Ini adalah nilai yang kita nak refer sekarang ni. Kita just nak refer ini je. Kita tak nak refer ni lah. Okay. X1 equal to X1 dot. Okay, sorry. Yang ni kita tak payah replace. The highest not need, let's say this is X1 dot. Sebab ini group yang pertama kan. Group yang pertama, X1 jadi X1. X1 dot akan jadi X1 dot. Ini sama lah. Tetapi bila kau tengok kat sini, ini X2 akan jadi X2. Bila kita differentiate X2, kita dapat X2 dot. Bila kita differentiate X2, kita akan dapat X2 dot. Tetapi adakah ia berakhir lagi? Ada lagi kan parameter selepas itu. Jadi sebabkan ada parameter selepas ini, itu pasal kita kena namakan dia sebagai X3.
Sebab formula dia minta satu dot ni kan?
Yang mana? Dah. Sebab soalan ni lah yang menyebabkan kita kena gantikan. Kamu hanya perlu ganti sekiranya dia belum berakhir lagi. Okey, saya tunjuk sini ya. Sekarang ni disebabkan ini X2. Bila kamu differentiate X2 dot, kamu dapat X2 dot. Bila kamu differentiate lagi sekali, dapat X2 double dot. Tapi disebabkan X2 dot sama dengan X3, kamu differentiate lagi sekali, kamu dapat X2 dot kan, double dot. Sama juga dengan X3 dot. Jadi, perlu tak kamu gantikan selepas ini? Tak perlu sebab dah berakhir. Kamu hanya perlu gantikan sekiranya ia belum berakhir. Okey. Sekarang ni baru masuk dalam equation ni. X1 dot, X1 dot sama dengan X1 dot. Tak payahlah kan? X1 sama dengan S1, X2 sama dengan S2. Tak payah tukar apa-apa. The most problem dekat second. X1 bersama dengan S1, X2 double dot sama juga dengan X3 dot. Lepas tu X2 dot sama juga dengan X3. X2 sama dengan X2. So that's why at the end kamu akan dapat X1 dot, X2 dot, X3 dot. So the keyword is, firstly kamu kena generate force equation. Lepas generate force equation, kamu kena extract X apa yang wujud dan kemudian kamu grouping X1 dengan S2. Kumpulan X1, kumpulan X2. Dari situ baru kamu boleh buat replacement.
So bila dia ada multiple je, dia akan mengira satu je. Macam seperti ada dua. Kalau ada tak lama ni K1, X1, dia akan consider satu saja ni. Satu jenis.
Satu jenis. I think to solve this one, I will upload the solution to get the eigenvectors.
I get lambda 100.
Lambda macam mana sekali?
Lambda 1.
After you implement this. Okay. After selepas kamu dapatkan value ni, kamu masuk dalam equation ni kan. And then after that to get the X value kan.
Oh, ini
So for lambda 1.
No, you this answer.
I do until here.
Why you don't use calculator? You get all three answers.
Use calculator.
Use calculator.
Oh.
Yeah. Got J. How you want to do yourself?
This one we use calculator. They unfortunately kan kita kira determiner apa semua kan for the matrix. Actually we can use calculator. Okay. However, for this example, for the transfer function we have lambda and so on, we cannot use calculator lah. However, for this thing, you can use calculator lah to get the answer. During the lecture, I told you that the use of the eigenvectors. Okay. Firstly, for the first half on the previous class, I teach you how to convert from the transfer function to state space. Okay. The first half kan. Let's say you have this kind of the transfer function. 10s something like that kan, and then you phase variable form and so on kan. In this process you need to convert to the signal flow graph, then you get the state space. Okay. But when you calculate the eigenvectors, you have the eigenvectors. So let's say this is transfer function. You got the phase variable phase. Okay, this is the state space lah. And then after that, if you want to turn to CCF, something like that, you need to get back to the transfer function. You need to follow this process to find the CCF. If you want to convert this thing, you need to get the transfer function and then change to the other form. However, when you get the eigenvectors, you calculate the eigenvectors, you can convert from the phase variable form example to cascade form example you not need to go back to the transfer function. You just can straight away to convert this thing by using the eigenvectors. There's a shortcut way. So normally to convert phase variable form to CCF, you need, let's say you have the state space in phase variable form. And then after that, you use the formula CSI minus A inverse B plus D to get the transfer function. And then after that, you need to use the signal flow graph and so on to get the CCF. Okay, the traditional way. However, when you have the eigenvectors, you want to convert the phase variable form to CF, you just use the information on the eigenvectors, just apply the eigenvectors here, then you can get the other. No need to get. Don't need to get. So this is what we use the eigenvectors lah. We call this as the transformation state space, something like that. So this is why you learn this thing, eigenvectors. Alright. Everything about the mathematics a lot of mathematics.
Want to apply to MATLAB.
Okay, boleh. Actually, yeah. You also you can check your answer lah during using the MATLAB. Actually, everything easy kan. You can calculate by using MATLAB. However, during the exam you cannot bring the MATLAB. So that's why we need to understand the fundamental lah. MATLAB dapat jawapan kan. Tapi tak boleh nak bawa. Exam tak boleh bawa MATLAB. Terpaksa lah. Okay. Alright, I think that's all for the class. So I need to end the session. So see you tomorrow during the class. Thank you so much.
Alright, Doctor, thank you.
Okay.
Thank you, Doctor.
Alright.